All right, let's go ahead and go over this. Okay, so you guys should already know how to deal with Pythagorean theorem. All right, there should be no contest about that. You've been doing it since middle school. So, all I had you guys do was solve these four triangles using a squared plus b squared is equal to c squared. And remember, c squared's always your what? C squared's always got to be your hypotenuse. So c squared's always your hypotenuse. So for this first one, if it helps, label A, B, and C. What's A? 7. What's B? The blank side. What's C? 25. You know C is your hypotenuse because it's directly across from the 90-degree angle. So this would be 7 squared plus B squared is equal to 25 squared. So that would be 49 plus B squared is equal to 625. Subtract 49. B squared is equal to what? 625 minus 49, what is it? It's what? 576. Square root both sides. What'd you guys get for B? 24. So B is equal to 24. And that's what you should have done for all of these. So I'm not going to do Pythagorean theorem for all of them. I'm just going to tell you the answers. So for 4, this side's 8. For 2A, it's 52. And for 2B, it's 48. How'd you guys do? Does anyone need me to go over another one? Or does anyone have a question on? Is there any that you have a question on? Which one? 2B? Got it. Okay, so for this one, it's pretty much the same setup as the last one. This would be A, C, and B. So you have 14 squared plus B squared is equal to 50 squared. This would be 196 plus B squared is equal to 2500. Subtract 196 to both sides. B squared is equal to what? 2304. And then you just square root that in your calculator. You can do a square root in your calculator. So if you do B square root of 2304, if you do that in your calculator, it's 48. So guys, I know it's big numbers, but they're all going to be perfect squares. You just got to do them in your calculator. Now, the reason I had you guys do these is it brings up a concept called Pythagorean triples. So a Pythagorean triple is just a set of numbers that if you ever see this particular set of numbers, automatically you should already know what the missing side is. All right, so Pythagorean triple is a set of 3 non-zero whole numbers such that A, B, and C will equal A squared plus B squared equals C squared. The most common one is 3, 4, 5. So if you have a right triangle, 3 and 4 will be its legs, 5 will be its hypotenuse. And if we check it, 3 squared plus 4 squared is equal to 5 squared. That's 9 plus 16 is equal to 25. So that's 25 is equal to 25. So it works. Basically, if you see like 3, 5, automatically you should know the other side's 4. All right, some other Pythagorean triples would be 5, 12, 13. 7, 24, 25, and 8, 15, 17. Those are probably the most common ones. Now, essentially, another thing is that if you have numbers that are multiples of those Pythagorean triples, you should already know what the answer is. You just got to figure out what the scale factor is. So, for example, this triangle right here, it's a 3, 4, 5 triangle. Because if we look, hypotenuse is 15 and 12. So if I solve for the Pythagorean theorem, this missing side should be 9, which they did over here, so I'm not going to check it. But if you look, what can all three of these numbers be divided by? All three of these numbers can be divided by 3. So if I divide all of these numbers by 3, what's 9 divided by 3? 12 divided by 3. 15 divided by 3. 3, 4, 5 triangle. All right, it's just a multiple of 3. So if we look at the ones that we did here, 7, 25, 24, that's just one of the triples that I gave you. 8, 15, 17, one of the triples that I gave you. But these other two, 20, 48, and 52, that is the 5, 12, 13. Because what can all three of these numbers be divided by? What can all three of these numbers be divided by? What can 48 and 20 be divided by? Bigger. 4. I can divide all four of these numbers by, all three of those numbers by 4. 20 divided by 4 is 5. 48 divided by 4 is 12. 52 divided by 4 is 13. So it's a 5, 12, 13. Now, if you don't remember the triples, just use Pythagorean theorem. It still works exactly the same as it should. All right. But if you do recognize some of them, it gets a little bit easier because then you don't have to actually do the math for it. You should already know what it is. Same thing with this one. So 50, 48, and 14, that is definitely a 7, 24, 25 because they can all be divided by 2. 14 divided by 2 is 7. 50 divided by 2 is 25. 48 divided by 2 is 24. So let's try a couple of these. All right, so 8, 12. So is 12 one of the numbers that's in the Pythagorean triple with... No, that's a 9. Never mind. Is there a Pythagorean triple that I told you that has a 9 in it? Yes or no? On that list that I gave you. No. So, but do 9 and 12 have something in common? What can they be divided by? So if I divide these by 3, this will be 3, this will be 4. So this is a what type of Pythagorean theorem? 3, 4, 5. So this is a 3, 4, 5. Meaning, since we divided by 3, that means I'm missing the 5 part. So how do I think I'm going to find the 5 part? What x is? We know this is going to be some form of 5, but what do I have to do with that 5? Multiply it by 3, because we divided by 3 here. So what's x equal to? 15. Didn't even touch Pythagorean theorem, and we got the answer. All right, number 2. Is there a triple with 12 and 13 in it? Yes. So automatically, what should be x? 5. It's a 5, 12, 13 triangle. Now this one, we know there's a Pythagorean triple with 25 in it, but not 60. So what did 25 and 60 have in common? What they can both be divided by? 5. So if I divide them by 5, this is 5, This is 12. So what type of triple is this? It's a 5, 12, what? 13. So that means that C has to be some form of 13. So what do I got to do with that 13? Multiply by 5. So what's C equal to? Didn't even touch Pythagorean theorem. Does everyone understand how these Pythagorean triples work? All right. And again, if you don't remember them, just use good old Pythagorean theorem. But this is one that can save you some time if you recognize that it falls under the triple. The biggest thing you got to take away from this is 3, 4, 5. If you remember 3, 4, 5, you're golden. The other three, great. But 3, 4, 5 is probably the one you'll see the most. Okay, I just wanted to bring that up. One other thing, go to the back side of that blue page. One other thing is that Pythagorean theorem can also be used to identify triangle type. So we know that if a squared plus b squared equals c squared, we know that it's definitely going to be what type of triangle? A right triangle. So if a squared plus b squared is equal to c squared, it's automatically a right triangle. Now, if a squared plus b squared is less than c squared, then it's an obtuse triangle, meaning it contains one obtuse angle. And then if a squared plus b squared is greater than c squared, so that means when you plug in a and b, you square it, add them together, and then you square c, and the two numbers, this side is greater than this side, that gives you an acute triangle, meaning you have 3 acute angles. Biggest thing you got to remember is this. Because you will be asked if, given this set of numbers, which one is a right triangle? Meaning, you plug it into the Pythagorean theorem and both sides of the equation should equal each other. If they don't, it's not a right triangle. And that's actually this last section of that delta math that I assigned yesterday. All right. So that's all you got to do. Okay. All right. Now, what I want you guys to do is take out that mathematic packet from yesterday. We're going to do that last part of it. So the special right triangle packet specifically. Yeah. And this is where you're going to need that protractor and that ruler. Now, while you're doing that, how many of you actually know how to properly use the protractor? Well, you got to learn. Yes. Yeah. All right, so everyone needs to look up at the board because I'm going to show you how to properly use the protractor. I got my big wood one up here. All right. So the next type of special right triangle we're going to learn is the other type. So yesterday we talked about 45, 45, 90. So just a quick review. 45, 45, 90 right triangle. All right, that means you have two 45-degree angles and a 90-degree angle. What's true about the two legs? So this is the leg, this is the leg, this is the hypotenuse. What's true about the two legs? They're what to each other? They're equal. So this would be x. How do I go from the leg to the hypotenuse? What do I do? It's on that paper from yesterday. How do I go from leg to hypotenuse? It's x times what? Square root 2. So that's a 45, 45, 90 triangle. The other one we're going to talk about is a 30, 60, 90. All right? So we're actually going to create a 30, 60, 90 triangle. So first thing we're going to do is we're going to place a point C anywhere on the horizontal line. So pick somewhere on this horizontal line and put a point on it. Doesn't matter where, just pick one. Doesn't have to be where I put it either. You can put it over here, you can put it closer, whatever you want to do. It needs to be on this line. We're going to label it C. Now, this is where the protractor comes from. So on your protractor, you should have either a little hole in the middle or you should have like a little line in the middle. All right? Does everyone see that little hole or that little line? What you're going to do is you're going to line up that little hole or line with the point that you just planted. Now, we want a 30-degree angle to go through this vertical line. So make sure your protractor is also, the bottom part of your protractor is also lined up with this horizontal line. You want to be accurate. So does everyone have their protractor like this? All right, now, we want to go through this line, so we're going to look on the left side of the protractor where 30 is. So what you're going to do is you're just going to make a little notch over the 30 degrees. So once you line it up, you're going to make a little notch with your pencil where the 30 degrees is. And you're going to pull the protractor away. So this notch that I just made, this is 30 degrees from this point. So everyone got that? Now, then you can either take your ruler or you can use the straight side of your protractor, either way. What you're going to do is you're going to go through the point that you made, line it up with a little notch, and you're going to draw a straight line until it gets to that vertical line. So it should look something like this. And just like that, you just made a 30-degree angle. So this little angle right here is 30 degrees. And we're going to call this point on the vertical line A. Is everyone able to make it? And lo and behold, you now know how to use the protractor. Now, we want to know what angle point A is, so we're going to measure that. So take your protractor again, and now you're going to line it up with point A. And make sure that the straight side lines up with the vertical line. Make sure the dot, the hole, or the line lines up with point A, and that your protractor lines up with the vertical line. Now, then you're going to look to see where that line you just drew lines up on the protractor. Where should it line up at? 60 degrees. So it has two angle measures, 60 and 120. You kind of have to use some logic here. Does that look like it's going to be an obtuse angle? Does this angle look like it's going to end up in an obtuse angle? No. So it has to be the 60. So this angle is 60. And what is definitely this angle? 90 degrees. So you guys just made a 30, 60, 90 triangle. All right. Now we're going to do some stuff with this. So this is definitely where you're going to want your ruler. The protractor we're pretty much done, but now we got our ruler. Yes. They're in that clear bucket. All right. So now the next thing that you're going to do is so we determined that for number 2 it's a 60-degree angle. So without using your ruler to measure, which leg do you think is going to be shorter? A, B, or B, C? So A, B, and B, C is the 2 legs. Just kind of from context clues, which one do you think is shorter? Definitely A, B. How do you know? It looks shorter, but what else kind of leads us to that fact? What angle is AB directly across from? What angle is AB directly across from? So if you drew a diagonal line from that side to an angle, which angle would it hit? So if I drew a diagonal line from this side, which angle does it hit? 30. Isn't that the smallest angle in that triangle? That's why it's the shorter leg. It's opposite the 30-degree angle. All right, now using your ruler. Okay, using your ruler. And you're using centimeters, not inches. So which side of your ruler are you using? The one with the smaller indents or the one with the bigger ones? Smaller. You're going to measure each side of your triangle and label them. So go ahead and do that. And remember, not all of your sides will be the same because you didn't put the point in the same spot. So use your ruler and measure each side of your triangle and write it down. So everyone should be doing that. can. So if it's like a half or a fourth, just try and get the best you can. Okay? Don't round to the nearest. Get it as close as you can to what it actually is. Okay, so my angles are not going to be the same as yours at all. Okay, so I can't really give you a check for that. I can just tell you what mine are. So if I measure it based off of the big ones on the board, this is about 27 centimeters for me, 17 centimeters, and 33 centimeters. Actually, no, it wasn't 33, it was 34. It was 34. Yes. So, okay. Now, about how many times bigger is my hypotenuse than the short leg? So we already said that this is the short leg, this is the long leg, this is the hypotenuse. How many times bigger approximately? So if you divide your hypotenuse by your short leg, what do you guys get? So go ahead and do that. Take your hypotenuse and your short leg and divide them. Tell me what you get. Yeah. What'd you guys get? What'd you guys get about? Did you put it in your calculator?
About 2.
About 2. And that is true. So typically your hypotenuse is equal to twice your short leg. That's always actually true. And it should be the same between all your group mates. So is that what about everyone got? About 2? Pretty darn close to 2? All right. So if this is the hypotenuse, first off, which is my short leg? This leg or this leg? the bottom. This is the short leg. So this is the hypotenuse, and that's 16. What should the short leg be? 8. Just divide it by 2. This is the hypotenuse. Which one's the short leg? The side or the bottom? Side. Because it's across from the 30. So this is 10. This should be what? 5. Okay, this last one, they gave us the short leg this time. So what's the hypotenuse? Times 2, which is 18. So 9 times 2 gives us 18. Now, how many times bigger is the short leg than the long leg than the short leg? So take your long leg. Mine was 27. I'm going to divide by 17. And it's not going to be a pretty number, so just round it to like the nearest, let's say 4 decimal places. So mine was approximately 1.5882. Is that about what you guys got when you divided? About what you guys got? Yeah. So the actual reality is this is about the same as the square root of 3. So if I put the square root of 3 in my calculator, it's really close to about what we got. All right, now it wasn't going to be exact, but it is actually a square root of 3 bigger than the short leg. So in other words, to get the long leg, all you would do is multiply the short leg by the square root of 3. So 30, 60, 90 triangles on the next page. This is the quick notes for it. So a 30, 60, 90 triangle is obviously a triangle that has a 90-degree angle, a 30-degree angle, and a 60-degree angle. Now, unlike 45, 45, 90, where we call it leg, hypotenuse because the legs are the same, the leg sizes are different on a 30, 60, 90. So we have the, oops, I put the 30 and the 60 in the wrong spots. This should be the 30. This should be the 60. If you go diagonal from the 30-degree angle, that should be your shorter leg. If you go diagonal from the 60-degree angle, that's your long leg. And if you go diagonal from the 90-degree angle, that's your hypotenuse. Now, your short leg, its length is typically x. Your hypotenuse, its length is typically 2x. You take whatever the short length is, multiply it by 2. And your long leg is typically x square root 3. Meaning you multiply it by the square root of 3. Now, some key facts is, let's say you're going from short leg to hypotenuse. All right, how you get there? You take your short leg and multiply it by 2. See, multiply the short leg by 2. If you go the opposite, hypotenuse to short leg, you take your hypotenuse and you divide it by 2. Now let's say you're going from short leg to long leg. You take the short leg and you multiply it to the square root of 3. Go in the opposite direction, long leg to short leg. You take the long leg and you divide by the square root of 3. And make a note, just like we did when we did the square root of 2 yesterday, you may have to rationalize the denominator. Now, something important to note as well is if you go from long leg to hypotenuse or vice versa, so if you're trying to go from long leg to hypotenuse or hypotenuse to long leg, you must find the short leg first. There is no direct way to get from long leg to hypotenuse. You have to, the middleman is the short leg. You got to find the short leg first. So let's say I was going from long leg to hypotenuse. I would go from long leg to short leg first. So I would divide by the square root of 3. And then I take what I got there, multiply by 2 to get to the hypotenuse. If we go backwards, so hypotenuse to long leg, I have to divide by 2 to get to the short leg. Take that short leg length, multiply it by the square root of 3. Any questions on that? All right, so let's try a couple of these. So we're going to find the missing sides. Now, what I always tell students is label your sides first. So this 4 right here is going to be the what? That's the short leg because it's across from the 30 degrees. What's this side? It's the long leg. It's across from the 60. What's this side? Hypotenuse. So if I want to go from 4 to the hypotenuse, what do I have to do? Multiply 4 by 2. What's 4 times 2? 8. If I want to go from 4 to the long leg, what do I have to do? 4 times the square root of 3. So what would that give me? Can I multiply 4 and the square root of 3 together and get a nice number? No, so it'd just be 4 square root of 3. We want them in exact with radicals. All right, look at letter B. So 15 square root of 3, is that my short leg, long leg, or hypotenuse? That's your long leg. It's directly across from your 60. Your short leg is here. Your hypotenuse is here. So which side do I absolutely have to find first? The short leg. How do I find the short leg from the long leg? Divide 15 square root of 3 by the square root of 3. What happens to them? They cancel. What am I left with? 15. Now I can get to the hypotenuse. How? Multiply the short leg by 2. 15 times 2, 30. Do you guys understand how you find these? All right. This next one says find the area of the rectangle, but we got to find the side lengths first if QO is 40. So this side right here, the diagonal is 40. Now, we know if it's a rectangle, that means this angle is 90 degrees. So if this angle is 30, what does this angle have to be? 60. So we can use special rights to find the 30, 60, 90s. So what side in O? Is that the short leg or the long leg or the hypotenuse? Short leg. What's in Q? Is that the long leg or the hypotenuse? Long leg, which means the diagonal that they gave us is the hypotenuse. You should do this every time you see a 30, 60, 90 triangle. Always label what the sides are. So, what side do I absolutely have to find first? Short leg. How do I get from it? Divide 40 by 2, which is what? So this side's 20. Then, how do I get the long leg? 20 times the square root of 3. So that's just 20 square root 3. So how do I find the area of the rectangle? I now got the two side lengths, the length and the width. How do I find the area of the rectangle? Length times width. So I'm going to do 20 times 20 square root 3. Remember, you just multiply the two outside numbers together. So my answer is 400 square root 3. 20 times 20 is 400. And then let's not do number 3. Any questions on the 30, 60, 90? So that was the last part of that 6.1 delta math that you needed. All right. Okay, now let's go into what I actually wanted to do today, which is the true trig stuff. So if you don't have a calculator, you need one. You need that pink sheet that you grabbed, and you need your packet, and go to page 5. All right, now for time's sake, it says to measure, but for time's sake, I'm just going to tell you what the side lengths are of these two triangles. All right, so you need to write these down. So this is 45, 32, 55. Yeah, it helps if it's unfrozen. Oh, wrong one. Sorry. So this is 35, 24, 42. And this one is 45, 32, 55. Okay, so they wanted you to measure it. For time's sake, I'm just going to give you the side measures. So that means if we rewrite these side lengths, BC is 24, AB is 35, AC is 42, DF or EF is 32, DE is 45, DF is 55. I'm just repeating the measures that I wrote up top. Now, let's do some ratios. So, this first ratio, BC over AC. So, what is that as a fraction? BC over AC. 24 over 42. Now, what I want you guys to do is put that in your calculator, 24 divided by 42, and round it to the nearest two decimal places and tell me what it is. So what is it? Anyone, what is it? Two decimal places, rounded to it. 0.57, good. AB over AC. What's that as a ratio? So what's the fraction first? Come on, guys. 24 over what? 42. So what's that as a fraction?
0.57.
Good. And then the last one for this row, BC over AB. So what's the ratio? Yeah, it should be. What's the ratio?
24 over 35.
Okay. So what is it?
0.68.
0.69 actually. Oh, yeah. This isn't 24. This should be 35. So that is 8.3. 0.83. All right, let's do the other side. So EF over DF, what is that as a ratio? So what's EF?
32.
What's DF?
55.
Yeah, 55. So if I do 32 divided by 55, what do you guys get? 0.58. All right. If you do DE over DF, so that would be 45 over 55. What does that give you? 0.82, actually, if you round up. And then the last one, EF over DE. So that would be 32 over 45, which will give you what?
0.71.
0.71. So, part B, given the column, the ratios you calculate in the above column, should they be equal for the two triangles or at least pretty close? What do you guys think? Yeah, they should be pretty close. Because if we think about it, these two triangles should be what to each other? We talked about it yesterday. They're similar. And we can tell by angle because we got two sets of congruent angles. So these two are similar by angle, meaning the ratios that we calculated, like we did yesterday, should be pretty darn close. So yes, they should be equal because the two triangles are similar by angle. That's why we talked about similarity yesterday. Now, let's say we had a third right triangle with an acute angle equal to 35 as shown below. Using your answers in the table, find the lengths of ST and RT to the nearest tenth. So let's think about it. ST and RT. They gave us RS. And they want us to find ST and RT. So what we're going to do is we're going to use one of these ratios up here. So if I wanted to find ST, so let's call that X. Let's say we used ABC. Which ratio would look like RS with ST if we look at corresponding sides? It's what? AB over what? Which ratio would make the most sense to use? The red, the green, or the blue? Look at corresponding sides. So I have RS and ST. What are the corresponding sides to RS and ST based off of their position? If we look at this triangle, come on, guys, we literally talked about this yesterday. AB and BC, which is the only ratio that has AB and BC in it. Has both AB and BC in it. The red, green, or blue? The blue. So we already know that if we do if we do ST over RS, it should equal 0.69 because that's what this ratio is. So essentially, we're setting ST over RS equal to BC over AB because those are corresponding sides. So if I plug in what I got for RS and ST, so I have X over 18 is equal to 0.69. How do I solve for X?
Times the size by 18.
Good. Times both sides by 18. So X is approximately what? So what is X approximately? Should give you to 2 decimal places.
12.42.
Yeah. Now, I say approximately because we rounded the value in the table originally. All right. So that's why I say approximately. So what I did is I took what we already got for BC when we evaluated it and I used that number. Does that answer your question? So let's say I wanted to find RT now. So I'm going to use Y. I still want to use RS. So I want RS and RT. If I still look at triangle ABC, what are the two corresponding sides to RS and RT? So look at the position. What are the two corresponding? What's the corresponding side to RS? We know that's AB. What's the corresponding side to RT?
AC.
AC. Which, so someone besides Owen, which of these ratios uses AB and AC? The green. All right. So we're using AB over AC. We're going to set equal to AB is on the bottom, so that should be RS over the hypotenuse RT. We already know AB is 0.83. So AB is going to be equal to 0.83. And then we're going to plug in the sides. So we got RS, which is 18, over Y. Now, this one I recommend cross multiplying. Okay, so put the 0.83 over 1, cross multiply. So we got 0.83y is equal to 18, because that's 8 times 1. How do I solve for y? You know I got an electric one, right? It's probably not plugged in. So, what do I do to solve for y? What do I do to solve for y? I already did cross multiply. What do I do? Guys, if you can't solve a one-step equation, I'm concerned. What do I do? Someone besides Owen. I know Owen knows. Y'all need to participate. Come on. I already cross multiplied. I do what? Divide by 0.8 by 0.83. So y would be what? Round to the nearest hundredth. Oh my God, guys, look in your calculator. 21.69, good. So these are my two values that we solved for. Now, why the heck do we even bother doing all this? This leads into our trig ratios. So essentially, this table that we set up was actually some trig ratios. And we use those trig ratios to solve for missing sides. So these are the three basic trig ratios. All right. Now, because all right triangles share an acute angle measure are similar, that means the ratio of the sides within a given right triangle don't depend on its size, but only its acute angles. This is known as trigonometric ratios or trig ratios, and it's based off of their relative position with respect to the acute angle. So all of these trig ratios are in respect to A. So A is what we call the reference angle. So this angle right here is known as the reference angle. Now, why is that important? Because that's what then tells us our trig ratios. So the first one is what we call the sine ratio. You may see it abbreviated as sin, but everyone says sine. So it says sine of A, so that's the angle, is equal to the leg of the opposite of A over the hypotenuse. So that would be BC over AC. So in other words, if I look at the side that's directly diagonal to angle A, that's BC. We call that my opposite. And then, of course, the hypotenuse, which is always across from the 90-degree angle. That is your sine. So all you got to remember for this is sine of theta, which theta is a Greek letter that we typically use to represent an angle, is equal to opposite over hypotenuse. So just know that theta is an angle. Cosine ratio. You may see it as COS. Still say cosine. So cosine of A, again, that's an angle, is the leg of the adjacent to A and the hypotenuse. So that would be AB over AC. So adjacent. Adjacent means next to. So if we look at A, all right, we're looking for the side that's not the hypotenuse that forms that angle A. So the hypotenuse is one of the angles that form angle A. The other is your adjacent. So that's AB. So every time we do a trig, you should always label opposite, hypotenuse, adjacent in reference to the reference angle. And they usually tell you what that angle is or mark it for you. And so that means that cosine of theta is equal to adjacent over hypotenuse. Let me write that up higher. Cosine of theta is equal to adjacent over hypotenuse. The last one, tangent ratio. You may see it as tan. So tangent of A is opposite of A over adjacent. So on this triangle, that would be BC over AB. So opposite over adjacent. So that means that tangent of theta is equal to opposite over adjacent. Now, all of this, you're maybe like, how in the heck do I remember this? Seems like a lot. Very easily. We call this SOHCAHTOA. And all it stands for is essentially what type of ratio and the actual ratio itself. So the first means sine, opposite, hypotenuse. So it means sine, you do opposite over hypotenuse. Cosine, adjacent over hypotenuse. Let me write that in a different color. Cosine, adjacent over hypotenuse. And then tangent, tan, opposite over adjacent. Now, you may still be like, well, that still seems like a lot to remember, like the acronym or the letters in the acronym. Here's a little mnemonic device to help you, and I swear to God, this is how I learned it in high school. Some old hippie caught another hippie tripping on acid. I kid you not, this is how I learned it in high school. This is literally how my teacher taught it to me in high school. Some old hippie caught another hippie tripping on acid. Some old hippie, that's the so, caught another hippie, that's the ka, tripping on acid, that's the toa. There's probably a nicer mnemonic device you can probably say for that, but you know what? You'll never forget that one because it's just weird. Yes. Yeah. All right. Now, these ratios are actually stored in your calculator, but what I actually want to do is that before I show you how to do in your calculator, I'll show your calculator stuff tomorrow. I want to show you guys how to use a trig table. So take out that pink sheet that I gave you. So, how a trig table works is there are 4 different parts. So you have A, sine of A, cosine of A, and tangent of A. A is obviously your angle. So whatever angle you're trying to find. And these 3 are the trig ratio of the angle. So sine of A, cosine of A, tangent of A. So for the first one, it says to find sine of 35 degrees. So what I'm going to do is I'm going to look down on my table and I'm going to find 35, which is right here. And I'm going to look on the column for sine. So that's the first column. 0.5736. So the way the trig tables work is that they actually went through and they found all of the sine, cosine, and tangents of all of the angles 1 through 90, which is really all you need because it only works for acute angles. And then they wrote them down here, rounded to the nearest 10,000. And that's the actual ratio. So this ratio for sine of So this ratio for sine of 35 is 0.5738. Just that exact number. What does that 0.57 remind you of that we already did previously in this lesson? Doesn't that look like the value we got right here in the red? Yep. So that red column, we actually calculated the sine of those 2 triangles. Now, cosine. So go back to your trig table. Still looking at 35. So what's your cosine?
0.8192.
0.8192. So this is 0.8192. Doesn't that one look familiar? Yeah. It's this column right here. Pretty darn close. All right, then finally tangent of 35. What's the tangent of 35?
0.7002.
0.7002. That looks like that last column that we had. Now, tomorrow I'll show you how to do it in your calculator because it's a whole. We have to talk about changing the mode in your calculator, and we don't have time for that today. All right, but just know for all the problems that you need for right now, you can 100% use your trig table. But that's how you use your trig table. You identify the angle, which typically the angle is right here. You look for that angle on your trig table, and then you look at the type of trig ratio they want. So sine, cosine, tangent, whatever. Now, let's do these last couple problems really quickly. So we'll work extensively with the calculator in future lessons. But now we need to get used to identifying the trig ratio with SOHCAHTOA. So, using different reference angles. So we're going to start with R. R is our reference angle. So before we even start, I need to label what is my opposite, adjacent, and hypotenuse. So looking at R, which side is my opposite? The 5, the 12, or the 13? Opposite. Opposite means it's diagonal from that angle. It doesn't actually form the angle. So what number is it? Guys, what number is diagonal from here? 5. That's my opposite in relation to R. What's my hypotenuse? 13. It's across from the 90, which leaves 12 to be my. What's the other one? Opposite hypotenuse and. I literally just said this like 5 minutes ago. You guys are going to make me like shoot myself. Come on. Adjacent. Good God. It's like pulling teeth. Okay. So that is in relation to R. So here's my recommendation. If you can identify the opposite and the hypotenuse, the other one's automatically adjacent. Adjacent's usually the hardest one to identify. Okay, just remember opposite is directly diagonal. Hypotenuse is always directly diagonal from the 90. And then adjacent is just whatever one's left over. So sine of R. Remember, sine is what over what? Opposite over hypotenuse. It's the so. So what is opposite over hypotenuse in relation to this triangle? What's the opposite of R? 5. What's hypotenuse? 13. That's the ratio. That's all we want. Cosine of R. Cosine of R is what? You can do it. Look at SOHCAHTOA. What's the part of the ka? What's the ka? What does A stand for? Adjacent over hypotenuse. Thank you. What's the adjacent side? 12 over 13. Tangent of R. All right, that would be what over what? Opposite over adjacent. So that would be what over what? Be 5/12. Now, for the next couple of ones, notice how the angle changes. It's not R anymore, it's T. So now we need to relabel in reference to T. So the hypotenuse is going to be the same. But now, which one is the opposite of T? 12. So 12 is the opposite. That's why I'm using a different color, which means the 5 is now the adjacent. So sine is opposite over hypotenuse. So what is the ratio? 12/13. Cosine of t is is adjacent over hypotenuse. So what is it? 5/13. Tangent opposite over adjacent. What is it? Nope. 12/5. That can happen. It doesn't have to be a nice fraction. Sometimes it's improper. All right, so we're not really going to talk about exercise 5, but your homework for tonight, okay? Your homework for tonight is pages 7 and 8. So use your trig table for some of these. Now, I will tell you right now what the side lengths are for the number 1 because it tells you have to measure. So the side lengths, I just got to pull up the one from the other day. The side lengths are 60, 26, 65. So write those down for number 1. 60, 26, 65. I will be checking this tomorrow. So make sure you get it done. It's only 2 pages. Shouldn't take you very long. 60, 26, 65. 7 and 8. 60, 26, 65. Those are the 3 numbers. Make sure you write those down. And again, use your trig table to define the sine and the cosine and the tangent of those values. All right, so here's what I need you to do. If I personally handed you the protractor, make sure they come back to me. The rest of the protractors and rulers need to go back in the boxes at the front. But if I personally handed you a protractor, you need to hand it to me. So if I personally handed you a protractor, you need to hand it back to me. Sorry the lesson went long today. It should not tomorrow. But you know what? You don't have a delta math, so yay. Just go ahead now, and then they'll write your notes class. Okay. Anyone else got protractors that I personally handed them? Anyone else got the protractor that I personally handed them? Ugh. Yep. Why'd you tell me earlier? Here. You went the entire class without telling me. Interrupt me. That's kind of important.
Go ahead and